Hello students, this is Niteen Mohod, and here through this video we are going to see that how interrupts can be executed in 8051 microcontroller. So here we are actually going to see the process. So when interrupt is activated in microcontroller 8051, it finishes the current instruction execution and saves the address of the next instruction to be executed on stack. Actually, the address of next instruction to be executed is always a content of PC, that is program counter register, and those contents of program counter register are placed on the stack. Then it also saves the current status of all the interrupts internally and jumps to fixed location in memory, which is called as interrupt vector table, and which holds the address of interrupt service routine. It's a program. Gets the address of ISR, that is interrupt service routine, and executes interrupt service subroutine till the last instruction, and the last instruction of interrupt service subroutine is RETI, that is written from interrupt. On executing RETI, microcontroller returns to the place where it was interrupted, gets program counter address from the stack, popping top 2 bytes or taking out top 2 bytes of the stack into the PC, that is program counter register, and resumes execution from the address. Now here we can see the different interrupts available in case of 8051 microcontroller and their ROM locations of ISR, that is interrupt service routine. So for reset, the ROM location is 0000H, that is ROM location of ISR. For external hardware interrupt 0, it is 0003H. For external hardware interrupt 1, it is 0013H. For timer 0 interrupt, that is TF0, it is 000BH, while for timer 1 interrupt, it is 001BH. And for serial communication interrupts, which are RI, that is receive interrupt, and transmit interrupt respectively, and which is actually a single interrupt, has got the ROM location of ISR as 0023H. Enabling and disabling the interrupts. So how the enabling and disabling of the interrupts took place? So on resetting microcontroller, all interrupts are disabled, means all interrupt bits will be 00000000, or they can be masked this way. Interrupts are to be enabled through software so as to be responded by the microcontroller, and for that one register is provided. Its name is IE, that is interrupt enable register, is responsible for enabling and disabling the interrupts. It is an 8-bit bit addressable register. It is called bit addressable register because on every bit of that interrupt enable register, the instruction can be written and can be executed. Means every bit of that particular register can be executed through an instruction. So here in the diagram you can see the interrupt enable register, which is a 8-bit register from D0 to D7, as you can see, and these are the different interrupts available. Now bit D7, we are starting from here, is EA, that is enable all. What is the meaning of this? It must be set high, means it must be 1, so that all other interrupts should take effect. Means what is necessary? Whatever may be the bit position of these interrupts is, the bit position of this EA has to be 1. When this is 1, then only all these interrupts will take effect, and if this is 0, no interrupt can take the effect despite of their bit position. If EA is equal to 1, means this bit is 1, all other interrupts are enabled and respond if their corresponding bit in IE is high. Means if this is 1 and this ET1 is 1, then this interrupt will be activated. But if EA is equal to 0 and ET1 is 1, then ET1 cannot be activated because EA is 0. The same thing is written over here, that if EA is equal to 0, no interrupt will respond even if associated bit in IE is high. So here you can see the bits of interrupt enabled registers and the explanation for. So first is IE.7th bit, that is interrupt enable register 7th bit, that is EA. If EA is equal to 0, it disables all interrupts, and if EA equal to 1, each interrupt source is enabled or disabled by setting, or means making 1, or clearing or making 0 concerned bit. This IE.6 bit of interrupt enable register is reserved for future use. Then ET2, that is IE.5, it enables or disables timer 2 overflow or capture interrupt, and this interrupt is used in 8052 only, that is 8052 microcontroller, which is the successor of 8051. Then ES, that is IE.4, enables or disables serial port interrupt. Then ET1, that is IE.3, enables or disables timer 1 overflow interrupt. EX1, that is IE.2, enables or disables external interrupt 1. ET0, that is IE.1, enables or disables timer 0 overflow interrupt, and EX0, that is IE.0, that is 0th bit of interrupt enable register, enables or disables external interrupt 0. Now we will see some examples which are actually dependent on this interrupt enabling and disabling, means the instructions related to these interrupts. So first problem is how all interrupts are disabled with a single instruction. Now we have shown here this interrupt enable register, and in the previous slide itself we have seen the details about this. This EA is enable all. If this bit is 0, then all other interrupts will be disabled. And what is required here? How all interrupts are disabled. So in order to disable all the interrupts, only one thing we will have to do, that is we will have to make this EA has 0. So now to make EA as 0, we will have to clear this bit. So the instruction can be written as clear IE.7, that is clear the 7th bit of interrupt enable register. And what is 7th bit? That is 7th bit is interrupt enable all. So enable all, when it will be 0, all others will be 0. All other interrupts will be disabled, and this way we can disable all the interrupts by using single instruction. Moving on to the second example, disable timer 0 interrupt using instruction. Now timer 0 interrupt is ET0, that is bit IE.1. So here the instruction is clear IE.1, that is mask timer 0 interrupt only. Then moving on to the next example, enable. Now here we will have to enable number of interrupts. Serial interrupt, that is this. Timer 0 interrupt, that is this, that is 4th bit, first bit, and external hardware interrupt 1, so 2nd bit. So we will have to make these 3 bits 0, and when these 3 bits will be made 0, we will have to take care that EA has to be 0. So in order to clear 4 bits, we will have to write the instruction either this way as move IE, that is move the data 10010110 into interrupt enable register. Why this will be data? Because hash sign is there preceding this binary number. So if the hash sign is preceding before this number, it means this is a data, or this will be treated as a data. So when this number enters into IE, you will get the bit number 4, then bit number 1, and bit number 2, external hardware interrupt 1, that is this bit number 2. So 1, 2, 4 and 7. So all these bits you can see 1, 2, 4 and 7, these bits are made 1. So it will enable all these 4 bits. Naturally EA is 1, therefore the remaining bits where we have made 1, they will take an effect. Another way of writing the same or getting the same effect is like this. Here for every bit we have written instruction. So for 7th bit we have written set B IE.7, 7, that is set bit 7, set bit 4, set bit 1 and set bit 2. So for individual bits we have written individual instructions, and that's why 4 instructions we have written, but here you can do it in a single instruction. So this is the alternative way of writing the or getting the same effect, you can say. So I hope the idea about the execution of interrupt in 8051 microcontroller, along with the examples associated with them and the default locations which are assigned to the different interrupts in ISR, is clear to you. Thank you.